Hello and welcome to the section 7.3 lecture. Today we're talking about absolute value equations and inequalities. So let's jump right into it. There's a lot of information in here. Some of it is a review, but there's a good amount that's actually going to be probably new, even if you've been through similar classes to this in the past. All right, so let's get right into it. First of all, absolute value. As a definition, absolute value is the distance from zero. Okay, that's kind of the easiest way to define it. So we're looking at the number 5. How many units is that away from 0? It's 5. 15, how many units away from 0? 15. 18, how many units is it away from 0? Sorry, negative 18 is 18 units away from 0. Negative 35 is 35 units away from 0. Okay, so we want to think about it that way. Now, is it a little bit easier to just think that it's just the positive version of whatever number I have? Yes, it is. Okay, but it's kind of interesting to think about what answer or what numbers in here would give us 15 as an answer. And that's really what we're looking at next with solving absolute value equations. Okay, I am looking at what numbers could I put in here to get a 5 as an absolute value. So just this one right here. What numbers can I put into this spot right here and get 5? Well, 5's obviously one of them. So it could be 5. But is there another number that when I take its absolute value, I get 5? There is. It's called negative 5. Right? Because negative 5 is 5 units away from 0. More commonly, you might see this answer written as plus or minus, I was going to say plus or minus 0, and that doesn't really make sense. Plus or minus 5. That means positive or negative 5. Okay, what about this one? Absolute value of x equals negative 4. Now, you may be inclined to think, well, it's got to be 4 and negative 4 because that's what we did over here. But that would be incorrect. Is there a number that I can take its absolute value and get negative 4, the key word there being negative? I cannot have any absolute value equal a negative number. That gives me no solution. It's easy to see here because there's no number that I can put in there and equal a negative value. That's going to come up when we get to solving equations. There's going to be cases that we get down to that. And once we see something like that, we can jump right to no solution. We don't have to do the steps that we're going to talk about below. So when we have multi-step absolute value equations, I do have 3 pretty simple steps that kind of get us to our end goal. First of which is to get the absolute value by itself. Okay, get the absolute value by itself. So when I'm doing that, I kind of think of the absolute value as a variable itself, and I'm just isolating that entire absolute value. We'll see that come into play in some of these problems. So get the absolute value by itself. The next thing I want to do is I'm going to say break apart the absolute value. And what that means is if I have, instead of writing this way, which is kind of a common way to write it, it kind of looks weird. I'm actually going to even make that in a different color because I'm going to use that. So when I have the absolute value of something, and I know this is kind of tough for you to do because you probably don't have different colors that you're writing with. But what this means is we're going to turn our absolute value equation into 2 separate equations using this idea right here. That when I have absolute value of x equals a number, it means that x equals either the positive or the negative version of that number. We're going to end up with 2 equations here. We're going to have whatever's inside the absolute value equals the positive version, and we're going to have whatever's inside the absolute value equals the negative version of whatever's on the right-hand side or the other side of the equation. Okay, then step 3, relatively simple. Solve the remaining equations, if there's anything to do. Okay, and that's always how my step-by-step processes go. Like, we may not have to do any work to get the absolute value by itself. Like in this first one here, the absolute value is by itself, so that one's done. Now I want to break apart the absolute value into the positive and negative versions. So that's what I'm doing here. I'm taking this, and it's going to equal positive 5 or negative 5. Okay. So we get x minus 2 equals positive 5, or x minus 2 equals negative 5. And so I'm taking those absolute value bars away, and I just have 2 equations. I want to solve those remaining equations. Add 2 to both sides. I kind of just, in equations, a lot of times I just kind of do both of them simultaneously because I'm doing the same thing here. Since I have x minus 2 in both equations, I'm doing the same thing, so I just kind of go through and do it. And there's going to be one place where I get different answers. So I get x equals 5 plus 2 is 7, or x equals negative 5 plus 2, which is negative 3. And that's my answer. Absolute value equations, more often than not, have 2 answers. Okay? Sometimes they could have 1, but that's a pretty special case. I'm not really... We'll see when that happens, if it ever happens to us. Okay, but let's get through these. All right. I want to get the absolute value by itself. It's not by itself right now. Again, I kind of mentioned treat this whole thing as a variable. Maybe treat it as y. And so this equation really just says y plus 10 equals 5. What do I have to do to get y by itself? Even though there's no y in this equation, I just put it there. Subtract 10 from both sides, and I get the absolute value of 3x plus 5 equals 5 minus 10, which is negative 5. Now here's the question. This is where something comes into play. Can I have an absolute value equal a negative number? It's this problem right here. No, I can't. That's a no solution. You don't have to go any farther, because the only thing that you would be able to do to go any farther, that next step would be incorrect. Like if you broke it apart and said 3x plus 5 equals negative 5 and 3x plus 5 equals positive 5, that's an incorrect statement. Okay. This next one, I want to get the absolute value by itself. Let me switch some colors up here. It's being multiplied by negative 10, and it's being added to 7. So we're going to subtract 7 from both sides first. So when I do that, I'm only doing it to this single equation because I have to get this absolute value thing by itself. I get negative 10 divided by negative 10 times the absolute value of m equals negative 60. And you might be looking here like, hey, you said it couldn't be a negative. Well, it can't, but I don't have the absolute value by itself yet. What happens when I divide both sides by negative 10? That gives me the absolute value of m equals negative 60 over negative 10 is positive 6. So that does work. I don't get to say no solution on this one. Okay, and then I break it apart, and then I don't have to solve a remaining equation because I just have m in here. This means that m is going to be equal to positive 6, or m will be equal to negative 6. There's no equation left to solve. It's kind of nice. I do have a lot of problems on here. We probably won't do them all in class, but I feel like I need to do them all here so that if you do them in class, you can go back and check what you have. This is always a weird thing right here when I'm solving this. Again, I'm treating this absolute value like it's a new variable. I'm kind of treating that like my y. And this 5 minus 7 times all this, I have a lot of students that want to jump right to, oh, that's negative 2 times the absolute value of 6 minus m equals negative 58. That is incorrect. Okay, why is that incorrect? Because the 7 is being multiplied by that absolute value. So we can't just do that. We actually have to take it step by step, subtract the 5, and I get negative 7 times 6 minus m, and that's going to be a negative 63. Divide both sides by negative 7, and I have 6 minus m equals positive 9, absolute value. Okay. Split it apart. I get 6 minus m equals 9, or 6 minus m equals negative 9. Kind of flowing over into my other problem there. Okay, I can subtract 6 on both sides. Oops, this side, and this side. And I end up with negative m equals 9 minus 6 is 3, or negative m equals negative 9 minus negative 9 minus 6 is negative 15. I should divide by negative 1 on both sides, or just flip the sign. I get negative 3, or 15. Kind of move this stuff over a little bit so I don't take all the room away from that other problem. This next one, we'll subtract 10 on both sides. So you can see I'm trying to get my absolute value by itself. It takes a little bit of work sometimes. Okay, and then make sure that you don't think this is like 14x minus 11. Do your best to make that a little bit bigger. Okay, so you realize that that's absolute value. It's a pretty common mistake. We just want to make sure that we don't make that mistake. All right, I need to divide both sides by 7. I get absolute value of 4x minus 1 equals 1. So then we break it apart. 4x minus 1 equals 1, or 4x minus 1 equals negative 1. We can add 1 to both sides. Kind of like all 4 sides. And I get 4x. I'm going to run out of room again. Let me just make this a little smaller. Now it's hard to read, but that's okay. I get 4x equals 2, or 4x equals 0. If I divide by 4 on both sides, I get x equals 1/2 over here. Dividing by 4 on both sides gets x equals 0 over here. And I didn't like to highlight my answers a little bit. I did not do that. I apologize. Okay. Next one, same kind of process. Subtracting 7. Then I'll have to divide by something. Divide by 3, it looks like. And over here, we're going to get, what do we get there? 27. Yeah, 27. Divide by 3. Divide by 3. Cancels that out. 3b plus 6 equals 9. And that's absolute value. So now I want to split it apart. So 3b plus 6 equals 9, or 3b plus 6 equals negative 9. Again, this is almost overkill with this many problems, but we're just trying to do your best to get through them. You do have the ability to pause this video and catch up with any writing that you don't keep up with, but we're really just solving equations. Okay, it just ends up that every one of these problems ends up with 2 equations. We get 3b equals negative 15 again. All right, now dividing by 3, and again I've ran out of room. You'd think I'd learned my lesson. No. No, no, no. Why would we do that? Dividing by 3, I get b equals 1, or b equals negative 5. Okay? It does say that you should try these ones. If you want to pause the video and go and give those a shot, feel free. Just in interest of time, I'm just going to keep working. Here we go. Multiply by 8 on both sides to get that absolute value of b by itself. 2 times 8 is 16. So absolute value of b equals 16. So b equals, quick way to write it, plus or minus 16. Okay, this one we've got to do a little bit of solving work first. Good news is we don't have any solving work after. It's going to be negative 10. Divide by negative 10 on both sides. You get absolute value of n equals 1. So n equals plus or minus 1. Subtracting 3 on both sides. 8 times the absolute value of x minus 9 equals 48. When I divide by 8 on both sides, I get x minus 9 equals 6. And so x minus 9 equals 6, or x minus 9 equals negative 6. Add 9 to both sides of both equations. X equals 15, or as a shorthand, you don't necessarily have to write x equals again. You could just say or 3. Getting 3 from the negative 6 plus 9. Okay, so that's absolute value equations. We're going to move on to absolute value inequalities. So let's go ahead and take a look at what that looks like. Okay, we have some rules. Some and rules. Each absolute value equation or inequality is written as 2 equations or 2 inequalities joined by an and or an or. I'm not going to go too deep into why this happens. And we're just going to, for now, accept it and stick with it. Okay? And I'll kind of give you a generalization of how we can try to remember what happens. Okay? A big key here is the ands happen when in the absolute value is less than a number. Okay? So this happens when absolute value is less than or equal to, less than or equal to, anytime that, I get stuck thinking this way too, anytime the arrow is pointing at the absolute value. Okay? Anytime it's pointing at the absolute value, it's an and. Everywhere else, it's an or. Equals, we already dealt with. It's an or. If we're trying to say that the absolute value is bigger than a number, that's also an or. And let's look at what that means. Let's look at these 2 examples. So I've got absolute value of x is less than 5. Well, if we split that up, okay, let's split that up. That means that x is less than 5. And then we know that it should be an and in here, but we can kind of just leave it blank and think for a second. If I split that up the same way I did with equations, there's an added step that I have to do. Since I'm going to deal with the negative version of that number, it's like multiplying it by -1. And when we multiply an inequality by a negative, we have to flip our sign. Okay? We have to flip our sign. And what we're going to do on the number line is we're going to graph both of those. Say we have -5 over here and 5 over here, zeros in the middle. Okay? I think that's 5. 1, 2, 3, 4, 5, yeah. And 1, 2, 3, 4. Okay, 5, not quite. Right there. All right. So looking at that now, if I say that x is less than 5, so I'd get an open circle at 5, and I'm looking for numbers smaller, and then x is greater than -5, open circle there and shading to the right. If I were to shade both of these in their, individually, they would overlap and they would cover the entire number line. Okay? This comes to the solution as to why this is an and. We're looking at where they overlap. Anytime we're looking at an and, we're looking where the shading overlaps. Okay? Only where it overlaps. Even though this one goes past this 5 and this one goes past this -5, I'm only looking at where they're both true. That's what and means, where they're both true. In this one, I have x, absolute value of x is greater than 3. And so if I break that up, I should say greater than or equal to 3. And we also have the -3. I have to flip my sign because I'm dealing with the negative. And this one makes it a little bit more clear. If I have 0 here, I have 1, 2, 3. And -1, -2, -3. They are closed circles, and when I graph these, this one's looking for numbers bigger, this one's looking for numbers smaller. They don't overlap at all. So if it was an and problem, there would be no solution. Since this is a pretty general problem, pretty standard problem, we want that to be an or. And when it's an or, so when it's an and, you shade where they're both true. When it's an or, you shade where either of them are true. And so this one's true here, so we shade that. This one's true over here, so we also shade that. Okay? If all you get out of this, and again, you've got these notes, keep these notes, use these notes, especially these ones that are already typed out for you. And maybe we write that. That would be a good thing to write. And shade where both are true. Or shade where either are true. Okay? And understand the difference between both being true and either one being true. Okay? That's my biggest helpful hint there. Something that can help you through this. Okay? All right, let's get going on these before we get this too long. All right, now that I'm starting this and I already have my inequality isolated, so we're going to leave that where it is. We're going to split it apart. X plus 3 is less than or equal to 5. So on the first one, I'm always just rewriting what I have without the absolute values. On the other one, I'm flipping my sign and I'm making it negative. Now, I do want to go back and look. That arrow is pointing at the absolute value, so that means it's an and. Okay, I want to keep that in mind because that changes what I would shade. All right, so we're going to subtract 3 on both sides of each one. That's going to give me x is less than or equal to 2 and x is greater than or equal to -8. Okay. So that I don't have to count out units here, I'm just going to put units where they kind of make sense. I'm going to say that 2 is there, and I'm going to say that -8 is right there. Again, just in the interest of time, if you want to count them out and make sure that it's good, feel free to be my guest. I would kind of expect it on the mastery challenge. On the practice, we're more concerned about where we're shading, not about our scale. Okay? So it's greater than or equal to -8. Closed circle. And I just kind of go over it lightly to start. Right? I'm shading to the right because I'm looking for bigger. Less than or equal to 2, closed circle, shading to the left. It's going to be true only between the 2 points. So that's all I shade. I don't rely on the arrows for my answers. I do shade on these ones every single time because I'm kind of doing my scratch work, my kind of light pencil work. I can't really make anything light here. Make my light pencil work up above, full answer, final answer on the line. All right, let's look at the next one. Absolute value of -7x is greater than or equal to 14. Again, greater than or equal to, I'm thinking that's an OR problem. It's going to be an OR. Okay, so let's split it apart. 7x greater than or equal to 14, or -7x less than or equal to -14. Okay, I want to divide both sides by -7. Okay, dividing by -7 on both sides. X will be greater than or equal to 14 divided by -7 is -2, or x is going to be less than or equal to +2. I'm going to put a little more space between these than I really need because I do want to see what's going on here. Greater than or equal to, that means closed circle, and I want numbers bigger than -2, and I want numbers smaller than +2. Remember, an OR is shade both of them, so I don't even really have to do any pencil work. I could have just shaded this one, right, and that's going all the way across. And then I could have shaded this one, a little bit of overlap there, but this one's going that way. This answer ends up being everything would work, all real numbers. Because they overlap, they're going in opposite directions, and they're going to keep going because it's an OR. Okay, next one. Absolute value is already isolated. We're good to go there. I have x over 5 is less than 2. Oops, that's not an OR. It's pointing at the absolute value. So that is an AND. X over 5 greater than -2. Multiply both sides by 5. We get 10. And x is greater than -10. All right, so we got -10 here, +10 here. No matter what, you're going to have to mess with your scale on there. And we have greater than -10, less than +10. Shade where they're both true. They're both true only in between themselves. Okay, there we go. Let's try to get these done. I know there's a lot of problems here. That's kind of good, kind of bad. I'm going to add 6 to both sides. I'm going to stop showing that work just in the interest of space and time. Feels like a Twilight Zone episode or something. That's going to be greater than 7. Since it's greater than or equal to, it's going to be an OR statement. So I want to keep that in mind. I have -2p plus 3 is greater than 7, or negative 2p plus 3 is less than negative 7. Again, I'm only switching the sign on the number on the right, and I'm switching my inequality. I'll subtract 3 on both sides. Negative 2p minus 3 is going to be 4, or negative 2p minus 3 is going to be negative 10. Divide it by 2, I get that divide by negative 2. Again, I am dividing by a negative here, so I do have to flip my inequality again. That's going to be a negative 2, or p, flip my inequality, greater than, what do we have here? 5. So less than negative 2 or greater than 5. Throw negative 2 somewhere, 5 somewhere else. They are not equal to's, so they're going to be open circles. Less than negative 2 is over here. Greater than 5 is over here. And there we go. Shading where they're either true. Either one of them are true. All right, we got a tough one here. Fraction involved. Multiply by 5 on both sides to start. Since it's pointing at what will be the inequality, since it will be pointing at the absolute value, it is going to be an and statement. So we have 4n plus 5 is less than 5, and 4n plus 5 is greater than negative 5. Okay. I'll subtract 5 on both sides. 4n less than 0, and 4n greater than negative 10. That's going to end up a little bit ugly. This one's just going to be n is less than 0, and n is going to be greater than negative 5 halves is kind of the best way to say that. Okay? So that's like negative 2.5. So let's say we have negative 5 halves there. Say that we have 0 there. They are not equal to's, so we have open circles. Okay. Let's see, less than 0 is that way. Greater than negative 5 halves is that way. Shade in between them. Most of the time that you have an and statement, you are shading between them. But there could be situations where they kind of overlap. They're going the same way, and then you would just shade where they're both true, past the second one. But I don't think we have many of those. Right here, first step is to divide by negative 8. I'm dividing by negative 8, so I do need to flip my inequality. No matter what, whenever I multiply or divide by a negative, I have to flip my inequality. Now, this is important. It's pointing at the absolute value, so it is going to be an and statement. So I have 4x minus 3 is less than 1, and 4x minus 3 is greater than negative 1. I might run out of room there. Add 3 to both sides. 4x is less than 4, and 4x is greater than, adding 3, we have positive 2. Okay. This is going to be x is less than 1, and x is greater than 1/2. Okay. So greater than 1/2, I'm just going to say 1/2 is here. We have a really large scale here, and I have 1 right there. Open circles on both of these. Got a lot of open circles today. Greater than 1/2, less than 1, shade in between. Okay. 2 of the your turn problems. If you want to pause that and get that done really quick, that'd be awesome. I'm just going to go at it right now just to get it done. Okay. This one I'm going to have n, I'm multiplying by 4, n is greater, Oh, I can't do that yet. Can't do that yet. Come on now. N over 4 is greater than 1. Since it's a greater than, it's got to be an or. N over 4 less than negative 1. N is going to be greater than 4, or n is going to be less than negative 4. So let's give ourselves negative 4 there, 4 over there, 2 open circles, shading away from each other. It's all right, my writing's getting sloppy. My hand's starting to hurt. All right, now we've got one that we have to do a little solving on. So let's go ahead and get that done. We're going to divide by 4 first. 6 plus k, absolute value, less than 8. So now we want to split it up. We have, it's pointing at it, so it's going to be an and statement. 6 plus k is less than 8, and 6 plus k greater than negative 8. Subtract 6 on both sides. K is going to be less than 2. And when we subtract 6, greater than negative 14. I got negative 14. I got 2. Open circles, yet again. Greater than negative 14, less than negative or less than positive 2. Shade in between, shade where they're both true. And there we go. All right, so that's that. Sorry, yeah, a lot of problems. And a couple different topics there. This would typically take 2 days. We got to get through stuff a little bit quicker, so we're trying to speed it up. All right, as far as practice and application, for the most part, I would say a good practice is make sure that you get all the problems on the note pages done. If you want some additional, I would say stick to the evens. I'm looking at the wrong screen. I'm committed. Application. One, 2, and 3. All right. Hope that helped make a little bit of sense. It is a difficult subject. Some of it is easy. Make sure that you're really good at the equations. That's kind of the baseline, and then it definitely does ramp up when you start talking about inequalities. So get that done. Have a good day, and we'll see you in class.